Hey friends, Stephanie here. Welcome back to another HexDevs episode. Before we go to the episode, we want to thank Nate Berkopec for joining us on this episode about building thread-safe Ruby code. As some of you might know, we help out at Faker Ruby, and we had an open issue that was related to thread safety, and we were not quite sure how to fix that bug. So we sent a message to Nate, and he kindly accepted the invite. And not only did he help us understand the issue, how to fix it, but he also gave us a lesson on building thread-safe Ruby code. Something else that we want to share is that this episode, and actually all of our episodes, are sponsored by Get You Senior, a program that we developed to help experienced Ruby developers take their careers to the next level. And we also have our GitHub sponsor page. We have two sponsors, Valentino Stoll and Greg P., who have been supporting us. So thank you. And if you, dear listener, wants to sponsor our work, go to hexdevs.com/getyouSenior or to our GitHub page to see our sponsor page.
This is the HexDevs podcast. I'm Thiago.
And I'm Stephanie.
Today, our guest is Nate Berkopec. Nate makes Rails apps go faster. He's an expert in Ruby on Rails performance, and he runs a company called SpeedShop, a software performance company specializing in Ruby. He is the maintainer of Puma, one of the most popular Ruby web servers out there, and he's also the author of the book, The Complete Guide to Rails Performance. Thank you so much for joining us, Nate.
Hey, thank you very much.
Yeah, we just gave Nate some homework to do. We sent him an email.
Yeah, what the heck, man? I thought this was a podcast, not like a class I had to go take.
Well, we had an issue that was open on Faker about Faker not being thread safe. So we didn't know exactly what to do, how to solve the issue. And we thought it would be a great opportunity to bring Nate, who's an expert in all of that, to talk more about why Faker is not thread safe. And then we could also use this example to understand more how to build thread safe Ruby apps. So thank you so much, Nate, and sorry to give you homework. Yeah, so I would like to get started with a heads up about what caught your attention about the issue. Why is Faker not thread safe?
Yeah, so you brought me in and sent me this link to this report. So this was actually after you thought you had fixed the thread safety issue on Faker. And so basically in Faker, so if you're not familiar with Faker, Faker is like this extremely commonly used gem for generating fake data, usually in tests. So you can like ask for last names, first names, like all, it's just like anything you can think of. Faker can pretty much generate a random version of it, right? So Faker also works with locales. So you can have, you know, Japanese data, English data, whatever, right? So you need to tell it what locale it's going to generate that data for. So there is a setting, and that locale setting, I think has always been, I don't think this was changed ever, Faker : config .locale equals. Okay, so that was how you set it. You set that to a symbol, I believe. You would set it to, you know, en-gb or ja or whatever your locale is. So there was a PR for included in 2.23, which changed how this worked. And originally, and this was your PR, Thiago, right? Like the PR that I'm about to describe that changed, or is it not?
No, I just approved it.
Oh, you just approved it. Okay.
Yeah, I did the review, and then I'm pretty sure someone else worked on that. Yeah,
Okay.
yeah, it was someone else, but I gave my thumbs
It's still
up.
your fault. I see. Okay.
Yeah, for sure. It's everybody's
blame.
fault.
Each blame the reviewer.
So the way that this originally worked was Faker config, the module, had a locale class variable. So you would set the class variable with locale equals, and you would read it with locale, right? So that works. That's fine. It means that all threads and everything, like if you create a new thread, it's still going to read that same value, right? So that all works. But if more than one thread tries to write that value, we start to have problems, right? So somebody basically made an issue that was like, I use Faker in QA, and in QA, we're sending different requests that have different locales. And so the Faker data, Faker is like setting the locale in one thread, and then being that a different thread is reading that locale, which has now been overwritten. And we don't want that to happen. So basically the request was that Faker should be thread safe. But to rephrase this as more of like a story, the desired behavior is, and you can correct me, this is what I'm a little unclear on, so you can correct me if I'm wrong about this. I think the desired behavior is that we should set a default locale in configuration, like when we start the app, and if we don't say anything else, this will be the default locale. And then threads should be able to, in a thread safe way, change the locale on a per thread basis. Okay, so you could, if this feature was available, you could, in Puma or any other multi-threaded web server, you could set the locale in a maybe Rack middleware or something. I don't know, like in a around action in Rails. You would change the locale in Faker and then do whatever work you wanted to do. Run the rest of the action, and then in an ensure block, you could say set the locale back to what it was before. And that would be how you could change that locale, and then you could have like per request locales in a thread safe way. Is that correct? That sounded like the desired behavior to me.
Yeah, that's the desired behavior. I think we had that before, but it wasn't thread safe. And then someone wanted to have different threads and not have one overriding the locale on the other thread. And then that was fixed. But then the other person said, hey, but then you fix my setup now where I run this, I guess, in production, I think. And someone else runs it in production. And now if I use Faker in production and I set the locale, it only exists like in one of the requests, and then the others don't see that anymore. And so it's kind of like one fix broke someone else's setup, and then we have to fix both things now.
Right. So the change that was made to try to implement this story was that locale is no longer just a class attribute or a class class variable. It is it sets thread.current open bracket Faker config locale close bracket, and we're writing and reading thread.current some thread. Well, we thought it was a thread variable, and then you learned later in the issue as people read the docs, it's actually fiber local. So that was the change. The instance, the locale instance, I keep saying instance, it's not a class instance variable, it's a class variable. That class variable locale was removed. It was completely removed. And there's some other stuff in here which I actually haven't looked at. You have some other like thread.current use. Like you've removed basically several class variables, replaced them with thread.current is kind of the theme here. Like this locale setting is kind of the one I'm just going to talk about, because it's the one I looked at, and it's a good example of everything else here. So then the bug report comes in, and this person's like, this broke something else for me. So you set up a Rails app in Puma or other threaded web server. You set faker.config.locale an initializer, make a request, and then you get the fake data for the default locale for Faker, which is en. So the faker config.locale setting broke for all Puma users using more than one thread. Or actually, I think it should be any thread at all. So basically, it broke it for Puma completely. So let's talk about why that happened. Because I think if you understand why this happened, then like the fix here becomes more obvious. So how Puma works. So Puma, when it starts up, it has one process and one thread to when it starts itself. And depending on the mode you have it set to, it may or may not start other processes. But the important thing here is that when Puma processes requests, it sends the request into what we call the our thread pool, which has a different name in pool. No, I guess we just call it the thread pool. Yeah, so it's the Puma thread pool, and that thread pool has anywhere from 1 to X number of threads, where you set it to whatever you want. So the application request is always processed in a different thread than the thread that Puma was started with. So we start the Puma server, we initialize your application, run all the initializers, and then we create the threads for the thread pool. Okay, so that timing is important here because the initializer is run before we create the application threads that actually run the application requests. So that faker config.locale is called before those thread pool threads are created. Behavior of thread.current, and sorry, not thread.current, but this is the bracket method on a thread instance, instance method on a thread, you could say. So this is accessing fiber local variables, as the documentation points out. So in case you don't know, all threads have fibers. Fibers are lower level concurrency unit than a thread. So all processes have at least one thread, and all threads have at least one fiber in Ruby. Okay, so Puma doesn't do this, and your application might create new threads, but create new fibers, I should say. But Puma doesn't actually create new fibers. So for our purposes in this conversation, there are no like a thread. It is a thread variable because we don't have multiple fibers here. So the thing is like when you create these fiber local variables with the bracket method, they're not inherited. So there's a really great reproduction in this issue when you scroll down a bit, where someone made like the minimally required reproduction, and all they did was set the fiber in the current thread, set the faker locale, then create a new thread inside of that thread, set it again, and then try to read what that was. And it reproduced the bug in 10 lines of code. Really, really, first of all, as an open source maintainer, that's exactly what we want to read, right? We want to read the 10-line reproduction. It's perfect. So good job to that person that wrote that. So these variables are not inherited. So like Puma creates the thread pool to run the threads that actually run the app, and now this locale fiber variable is no longer set. So it goes back to the default value of English. So that was the source of the bug here. So does that all make sense? I've been talking a lot. Now I'm done talking.
Yeah, for sure. That makes a lot of sense.
Mm-hmm. Yeah, that was Mateus. He has been helping a lot with this issue. Like I am learning.
Yeah, I'm curious to know about, because you mentioned that the fiber local variable is not inherited by the other threads. But then if we talk about the class variable,
right?
If I set that class variable on the initializer, it would be available to all the other threads. Is that how it works?
Yes. Yep. And this is like, this is kind of the, to me, like the fine-grained part of this issue is like, when it comes to thread safety, it's just like people are like, okay, we got to get rid of all shared mutable state. Shared mutable state is bad, get rid of it. And that's like what the PR did, right? It nuked the shared mutable state. No more class variables, don't do it. But like you actually do want shared mutable state in this story. Like you want to be able to change the locale for all threads at a particular point in time, right? You want to do that during initialization when there when there aren't multiple threads probably trying to read this value and do stuff with it. Like there's not like you want to do that during a time when it's probably safe to do it. And then later you want the private state. You want thread private state, right? So it's kind of like a little bit complicated there where like you want both things, right? Like you want to be able to override this value for all threads. You just want to be able to do it at a particular time. So the original PR was thread safe, it just also didn't work. So you gain thread safety while breaking the feature.
Yeah.
Yeah, it's interesting that maybe thread safety is not always the goal, depending on your feature. Maybe you want to be able to share state between threads, and maybe if you want to mutate the global state, then you have to worry about thread safety and how you would approach that. But in this case, you broke the feature by doing that, right? Which is kind of interesting.
Yes. And sometimes it's also a little bit complicated here because you also don't, in this story, right? You don't actually really care about the thread safety of setting this locale for all threads. Like you could write this in such a way that like the class variable is that access and reading is thread safe. So like we could use something from concurrent Ruby, for example. It's a library, a Ruby gem that's used in Rails. And we could set this up so that it's thread safe to change the locale for all threads. But you don't really actually care about that because the only time you're going to do that is during app initialization. And so, or we could write our own thing with a mutex or whatever to do this. But you don't really actually care about the thread safety there because that happens during initialization where there's only one thread running anyway. So like you could add that to like, check all your thread safety boxes here. But what you really wanted was like private thread state. Like you want to be able to change this value on a per thread basis and not have it affect other threads. Okay. So that's like, to me, that's like a little bit different than thread safety. There's a thread safe way to implement this that would still not satisfy the story. If we just took the original behavior of the locale class variable and made that access thread safe, what would happen is every request would change the locale for all other running requests. So like in the middle of halfway through rendering a response, the faker locale could be changing because other threads are changing that locale value. That you don't want that, right? Like you don't want global state, you want per thread state. So like thread safety is more complicated than just it is thread safe or not, depending on what behavior you desire.
Yeah. And I also think it's really easy to create those bugs because I don't think most of us are aware of those details.
I think in general, this doesn't happen in application development because most of this, it's just like very uncommon to need to write or need to use class variables, for example. So the common sources of thread safety issues, generally you don't reach for these like tools that cause these problems in application development, but it does happen all the time in library development. So the most common causes of thread safety issues are class variables, global variables, which used to be a thing that people did, but I don't know. Mostly people don't even reach for them anymore and just use constants. Constants and Rack Middleware. So those three things, really constants is the only thing I see people making mistakes with in application development. But when you're doing libraries, class variables and Rack Middleware, it's very common to have those things. And so you need to know more about thread safety when you're writing libraries, I think, than writing Rails applications, for example.
Mm-hmm.
For sure. I'm curious about the cases you mentioned about like constants, that being a problem. Is that because people try to modify the value of a constant
Yes.
At runtime.
Yeah, exactly. Like setting a constant to like a collection, like an array or a hash. Those accesses are not thread safe. Even Samuel Williams, the maintainer of Falcon, the web server, has also had this demo where he's shown that hash access is not thread safe in hash access and write is not thread safe in Ruby. You can even like corrupt the hash, end up with all these crazy behaviors. So yeah, setting constants to collections and then modifying those collections. So there was like a trend, I don't know, like 2 years ago, no more than that, I don't know, 4 or 5 years ago, to like freeze constants. And we used to do this mostly as a memory saving measure. So like when you freeze an object, Ruby internally allows everyone that uses that constant can like point to the same object. So we used to like just put a lot of things in constants and freeze them. Now there's like this Rubocop rule that tells you to freeze everything you put into a constant. And freezing is nice from a memory usage perspective, but it's even better from a thread safety perspective, because now you get an error, right? If someone tries to modify the object, you can still get these problems though with freezing, because you can satisfy the Rubocop rule, right, by calling freeze on an array inside of a constant. But if you have a array inside of that array, Rubocop won't say anything, and you still have a thread safety issue because you're modifying this unfrozen array inside of the constant. So anything that's accessible from that constant really can lead to a thread safety issue. So I think I see that issue sometimes in app development where people create caches that they want to use. That's kind of the most common thing, is they put a cache inside of a constant and then they end up with a thread safety issue there. Or the other one I see is database connections. So if you put a database connection inside of a constant, for example, if you just like capital Redis equals redis.new, the issue you're going to get there is everybody accessing that constant is getting the same exact database connection. So if you have two threads accessing the same database connection, you could end up with issues where one thread gets the response for another thread. So you don't want to do that. And there's like a lot of gems that help you with this, but basically you need to set it up so that each thread is getting its own connection out of the connection pool. So those are the most common ones I see in day-to-day app development.
That's interesting. A good rule of thumb, maybe if you're working with constants and you're trying to do something weird or adding some hashes or arrays to the constant, you gotta be careful with what you're doing. Or a database connection.
Yep.
Cool.
And Nate, since you are talking about those common things that you see happening in development, is there something that we as developers could change how we see things when we're implementing them? Like, how can we start paying more attention to those potential thread safe issues? Because like you mentioned, it's not something that we do it every day. For example, nowadays, I think it's more common for us to know, oh, this is going to have a N+1 query or something like that. So how can we start changing our ways of working to also start identifying those issues?
Yeah, my biggest recommendation is always to make your tests multi-threaded. So if you are using Minitest, you can run each test inside of its own thread. It's called Minitest. Oh man, now I'm gonna forget. Let me get this Minitest, because I think, yeah, parallelize is what it's called. So if you require Minitest / parallel on a test, or no, include it. Now I'm not going to remember, but look it up. But yeah, you can set up Minitest so it runs each test in a different thread. So that covers your unit tests and makes all your unit tests multi-threaded. So if you're just running Minitest, I suggest turning that on. If you're using RSpec, you're out of luck. Sorry. RSpec isn't multi-threaded, never will be. So you're stuck. Your only option for multi-threaded tests is to convert them to Minitest. So, good luck.
I was gonna say, okay, what about our spec?
Yeah. For integration and system tests, so system tests start a Puma server, or integration test can, you can set up to do whatever you want, right? But you should set up your integration test to start a Puma server and run that Puma server with multiple threads. So that will also potentially flush out threading bugs. Now, this is also going to make your test suite less stable. Like, you can't make a threading bug, usually you can't cause it like 100% of the time. So you're going to start getting flakes probably where they're caused by threads. Like, you can't just like write a test that's like always triggers the thread bug most of the time. So it will probably make your test less stable, but like, that's kind of the price you're going to pay here. So that, to me, is like the best possible thing, is make your test multi-threaded so you are actually testing thread safety. Second thing is, like, all you can really do is look for those 3 different sources of threading bugs that I talked about anytime you're writing your own Rack middleware. So the thread safety issue here is that there is only one Rack middleware stack for an application, right? So like, the objects that are created that actually run your Rack middleware, there's only one of those for every application, or every process. So your application runs in different threads, but they're all using the same Rack middleware objects. So if you have an instance variable inside of a Rack middleware, you can end up with a thread safety issue. The fix here is actually really easy. There is a middleware freezer that Samuel Williams wrote called Rack-Freeze, and it basically ensures that your Rack middleware are thread safe by freezing all of your instance variables, and so you can't possibly cause a problem, and it'll blow up if you try to do thread unsafe things. So take a look at that for Rack middleware. For constants, I think probably everybody should audit constants created in initializers for this issue that I talked about. Basically, make sure what you're putting into constants is not a collection that's going to be modified, and is not just a straight up database connection. For database connections, there's a gem called connection pool. This is I think still maintained by Mike Parham. Yeah, so Mike wrote it. I think he wrote it originally anyway, but it's mparham from Sidekick, MPERHAM/connection_pool. This is like a generic connection pooler that works with any underlying database connection gem. So you can get thread safe connection pools that will work with threads. So you would assign that to a constant instead of just like redis.new. And then for class variables, those are a little bit easier because hopefully you can just find the @@ like looking for the @@ is like, control F your code base for that. But you in the original PR, actually, you had class inherits from self, and then it was @locale equals. So like, since you can always do that, it's kind of hard to like just grep through a code base for class variable usage. But if you see a file that has a class variable in it, that is shared global mutable state. So, it's only thread unsafe when someone tries to write to it from multiple threads. So just because these exist doesn't mean I think that you should be replacing them all the time. Often, like, one thing that happens is someone needs to write a value to a class variable, and then multiple threads want to read that value. If the writer method, if every thread will just write the same thing to the class variable, like initialize like a default value, and then everybody reads the same value after that, that's not really a thread safety issue because every thread is trying to write the same value, right? So it doesn't matter that they could possibly access the thread variable, class variable at the same time, because they're going to try to write the same thing. So who cares? So it's like, there can be shared global state without there being a thread safety issue. But I think you have to be aware every time you see a class variable or class instance variable that think about what is trying to write to this, and when is it trying to write to this, and could there possibly be an issue there?
Yeah, I like the questions to ask before you go out there and try to replace everything.
Because this is complicated, right? Like,
yeah.
especially with class variables, writing the mutex.synchronize stuff. Like, you've probably never written anything with mutex before. Pulling something out of concurrent Ruby that you've never used before and using like a data structure out of concurrent Ruby, like, it's not the easiest thing in the world. So, definitely try to avoid it if you can. Yeah, I mean, and people smarter than all of us have done that and then made a mistake anyway. So yeah, it's not easy stuff.
But maybe one thing that exacerbates the problem is that we are very used to thinking in Ruby is just like, it's just one thread and you don't have to use other threads or anything like that. Because compared to maybe other languages, when we say, oh, in Java, be careful with static variables and things like that. But in Ruby, we don't talk about that a lot, about concurrency, at least. Well, at least in Rails, like, oh, it's just, you don't have to worry too much about that. Request is one thread and you don't have to worry about those things. But then when you run into those weird bugs, you're not sure what to do. You just think, oh, I don't know what that is. I have no idea why this is happening. But if you try again, you're not gonna have the problem. And so I'm curious about what kind of things people can do so that when they run into a weird problem, they can point and say, oh, maybe this is a thread safety bug instead of something else. So maybe like some strategies or some characteristics of bugs.
It's pretty easy. Yeah, like if every time I hear one request, the request A got the response for request B. So every time I hear like, oh, someone is getting someone else's responses, and that's obviously a security issue, right? That's kind of how this usually comes up, is like, oh no, somebody got authorized to someone else's account because they got someone else's cookie header, something like that, right? So anytime I hear one user A got the response for user B, it's like thread safety issue immediately. So that's probably the most common one at the application level that I hear about. The faker issue specifically, I think maybe we kind of all knew because it was like, oh, it was this change, or like someone realized it was only in Puma. I guess that's the other, yeah. If switching to Unicorn fixes the issue, then you know it's a thread safety issue, right? So because in Unicorn you don't even have, there's no like, for example, so I talked about how Puma starts essentially, even in the simplest case, it has to start two threads. It has the thread that starts Puma and boots your app, and then the thread that actually runs the application, right? Technically, we're running your application single threaded there. Like the actual every request that comes in to that Puma process will always be processed by the same thread. So yes, like it technically is single threaded, but we kind of have this like thread issue, right, with faker, even in that scenario, because that thread Viper local variable was not inherited. So if moving to Puma breaks breaks the issue and getting off of it fixes it, then you know you have a thread safety issue. But yeah, I think generally, like any issue where state is kind of correct for one person but not correct for someone else, and it's flaky and random, then your thread safety issue spider sense should be tingling.
Yeah, and it's not Puma's fault either. It's just the way.
Yeah, I mean, it's your fault. Puma's thread safe. You're not. So wasn't me, man.
Yeah, that was a hard one, and we were like, I think we should ask for someone who knows how to fix this issue, because we were not sure. And I think it's also, it's something that I want to see more, is people saying, developers saying that they don't know things and they ask for help. So I thought this would be a a good way to do that.
Yeah, and like when I started maintaining Puma, I knew nothing. So like in 2016, when Evan Phoenix, the original author, like asked me to start maintaining Puma, like I didn't know anything about threads, thread safety, or all the other like kind of specific things that Puma needs to run, like knowing about sockets, TCP, UDP, like the deep specifics of HTTP, C extensions. Like I didn't know any of that when I started maintaining Puma, and now I know a lot more. But when I started, I didn't know anything. So like we all start not knowing anything. So you know, we everyone that you ask a question about thread safety or whatever, at one point they didn't know the answer to that either. So yeah, I don't think you should feel intimidated about asking questions like that.
And it's also a cool opportunity for contributors. So, for example, Mateus, who's taking a look at that issue, he said, "Oh, I don't know anything about threads, but I'll try to learn something." And then he learned a couple of
He did,
things
yeah.
and shared. And so
Yeah.
it's just a nice way to learn more, because you don't really have to know before you get started on an issue. And then eventually, if you continue working on that, you're gonna figure it out, and then we can have nice conversations about that. It's kind of cool.
Yep. And I think one thing that I'll bring it up again that Mateus did that was just like really important for that was to get the minimal reproducing case. So when he had that 10-line example that reproduced the issue, that's so important for learning, because then you have this little experiment that you can try things on. So you can say, oh, if I change this over here, how does that change the behavior in my example? If you don't have the minimal reproducible example, it's much more difficult to learn, because you don't have a little tool that you can change things on and see what happens. So getting to that minimal example was so important, I think, for where he went and the rest of the issue. So if I have any advice with that, is to like to emulate that behavior, to try to get to the 10-line example that reproduces the problem.
Yeah, I love that. It's a very underrated way to get started with not only contributing to open source, but I think almost anything related to development, let's say, because you get to just try. You're not trying to fix anything, you're just trying to find what is going on, and you learn a
Absolutely.
lot about
In
things.
Puma on GitHub, we have a needs repro label, as in needs reproduction. And I put that on any issue where the original poster has not provided a similarly simple example that can just be run and reproduced. So in Puma, if you'd like to contribute, that's one way to do it, is you go to the needs repro label and just try to reproduce people's issues. And I can tell you, as a maintainer, it's also helpful if you can't reproduce it and you leave a comment and tell us, you're like, hey, I looked at this for 3 hours, I couldn't reproduce it. That is super helpful for me, because now I know, okay, someone tried to do this for 3 hours and they still couldn't get it. Maybe this is not reproducible. Maybe this isn't actually a problem with Puma. So it's really helpful for an open source project to find issues which are not currently don't have a reproducible case, and to try to find one. So I highly encourage that.
Yeah. And just to emphasize, I don't think, well, I believe I can say that for you, but correct me if I'm wrong. We're not saying that if you don't know how to reproduce, you can't report the bug. But
oh yeah,
but if
you have a bug, right? So
yeah,
you should report it.
yeah. So everyone can contribute on their ways.
Yeah.
But yeah, reproducing is really great. I think that's also how we got started with Ruby on Rails, and we actually copied the reproduction script for Faker.
Oh yeah,
which is really, really helpful.
Yeah, if anyone listening is not aware of that, there's the Rails bug reproduction script is really very good, and I think those are available if you go to like the Rails contributing guide on Rails guides, and then like you kind of go down to the bug report section, you can find the links to all of them, and it's really cool, and it'll show you kind of in 30 lines how they set up a Rails app to reproduce an issue in the most minimal way possible, depending on what part of Rails you're reporting the bug to. And it's a really good example of how to make a minimal reproducible case, not only for a Rails app, but for really any Ruby project. So yeah, I've done the same thing. I've copied that script multiple times.
And I guess even at your own job, if you're not contributing or anything, maybe there's a way to use those kinds of scripts to reproduce a bug, so you don't have what is it called again when you don't want the bug to appear again.
Regression.
Yeah, regressions. You don't want regressions. So this is really important. So add a little test there so you don't have regressions. It's kind of a cool habit sometimes to have.
Yeah, absolutely. Well, I think we got to the end of it. So we only have 10 minutes left. Is there anything else, Nate, that you would like to share about the issue, either about the issue or about the conversation we were having?
Nope. I would say that if someone listening to this is interested in learning more about working in a multi-threaded environment, I do have a product called Sidekick in Practice that has a number of live code examples that talk about thread safety and have other. It's intended to be a manual about like how to actually scale Sidekick, and because it's Sidekick, there's a lot of things in there about threading and how threads work in Sidekick, why threads are important. It talks about the global VM lock, which we didn't really discuss at all today. But if you are looking to learn more about threads and scaling the threaded environment, I do sell something to help you with that. So go check it out.
Awesome.
Absolutely. It's in my reading list. I really need to get it. Which one should I read first? That one or the guide to Rails performance? I don't know.
I mean, yeah, it just depends on what your goal is first. They're not intended to, like, you don't have to read one to read the other. So if you're interested in a more general perspective of how do I make a Rails app feel faster, how do I make it more scalable, like that's the complete guide to Rails performance. If you are specifically having issues with Sidekick and scaling Sidekick, I suggest reading that first.
Yeah, that would be a nice episode to talk just about Sidekick, because there are so many things to talk about Sidekick performance. We could do that in the future.
Yeah, like how to log your workers, your scheduled workers, like how to, logging and debugging and
retrying jobs.
Yeah, I've had a lot of fun. My current client is Gusto, which is a huge payroll company in the United States, and they've got 600 plus engineers working on Sidekick, and it's been a really interesting experience to me to see kind of how Sidekick scales like as an organization. So like what happens when 600 engineers all have queues and workers, and like that's been a whole new side of Sidekick that I've learned a lot about at Gusto.
Yeah, it sounds really exciting work. A lot of problems and challenges to solve, which is kind of cool.
It's been really fun.
Yeah, and I think we're supposed to call jobs now and not workers. I'm still getting used to the new terminology. I need to catch up. I think I read something about that.
Oh, that's changed? I feel like I should know that, but I don't.
I don't know. I remember seeing a comment about that. Like, instead of being workers...
Can you change the folder in Rails or something?
Yeah, to jobs. I'm not really sure. I have to catch up. I just remember reading about that, and I'm like, oh, I'll probably need to read this at some point. So I think we are at the end, and I would like to be respectful of your time, Nate. But thank you so much. I learned a lot, and I know it was a bit of a homework for you, but I hope it was fun.
It was fun. Yeah, it was fun. It was fun. Nice to talk to you all.
Yeah.
Yeah, it was a very specific problem with a very specific solution. So it was nice to learn from that. I've learned a lot. So yeah, thank you so much for sharing your expertise with us today.
Great. Yeah. My pleasure.
And everyone, make sure to check out Puma and Nate's books on Sidekick and Rails performance. We'll leave the links in the description box.
If people want to know what you're doing or want to buy your books or your workshops as well, where should they go?
Speedshop.co. This is where I have links to all that stuff.
Awesome.
Cool. Thank you, Nate. Have a good weekend.
Thank you.
Thank you so much, Nate, for joining us today. And if you've learned something from this episode, please share with a friend and check out our newsletter at hexdevs.com/newsletter. I hope you enjoyed this episode. See you on the next one.